Okay, so this video is going to be on DNA replication. So let's start off by drawing a DNA molecule. Okay, and here you'll have the bases connected by hydrogen bonds. So this is our DNA molecule. How do we get this to begin replicating itself into two identical strands? Well, in order to do this, first we need to unwind and unzip the DNA molecule. And this is done using an enzyme called helicase. So what helicase does is, it first unwinds the DNA molecule. So you get this in a more 2D fashion. And then it unzips through the middle, breaking the weak hydrogen bonds. And this means we're left with this. This is our leading strand. And then we have our lagging strand. Over here, where I'm drawing right now, it hasn't been unzipped yet. But what helicase is continuously doing, it's continuously breaking these weak hydrogen bonds while the replication process is happening. And eventually the whole DNA molecule will become unzipped and fully replicated into two different strands. Now, over here we have our replication fork, which is where the DNA is split and where the DNA is not split meets. Okay, so here we have our leading strand. This will be 3' and the 5' end, and here's our lagging strand. So we'll make this the 5', we'll make this the 3' end. Now, what happens next? Here's our bases. Okay, so what happens next? Well, to begin the replication process, we need a primer, and the primer basically just gives DNA polymerase a starting point to begin replication. So let's draw a primer here on the leading strand. That's our primer. And what happens in replication is an enzyme called DNA polymerase continuously adds free DNA nucleotides to the leading strand. And it can only do this in a 5' to 3' direction. So what do we mean by this? This new strand will begin at a 5' direction and will end at a 3' direction. So it'll continuously replicate and add DNA nucleotides with matching bases to the complementary base pairs. And when the replication process is done, you'll have your 5' to 3' leading strand, and then the opposite strand, which is 5' to 3' in the anti-parallel direction. Now, in the instance of the lagging strand, which is this strand over here, we have a bit of a problem because we have to do DNA replication backwards. So instead of starting over here, we have to start from the replication fork. Now, in order to deal with this problem, what happens in replication is the adding of DNA nucleotides is done in fragments, in sections, and it does this discontinuously. So, and the enzyme, first we add the primer, so here's our primer, and then DNA polymerase comes along, and it adds a fragment, an Okazaki fragment, or an RNA fragment, so just one section of the DNA nucleotides. Once this is done, another primer comes and adds itself on over here, and then another Okazaki fragment adds on, and so on and so forth. Then, while this is happening, ligase, another enzyme, is used to join each fragment together. And when all of this completes and helicase completely unwinds and all the free DNA nucleotides have been added to the DNA molecule, we eventually get this. Which is two separate identical DNA. I know my drawing isn't that great, so it's not identical, but you get the idea. They're meant to be identical. Now, did not mean to do that. As you can see, we have our identical-ish DNA strands, and that's how DNA replication occurs. That's the process of DNA replication. Now, if you get asked a question on this, according to the mark scheme, this is what you'll have to write in order to get full marks. So if you're asked a question like explain the process of DNA replication, you'll get a mark for this. Let's see, type this. So DNA unwinds into two strands. That'll be 1 mark. Our second mark will come from us writing that a primer is needed to start replication. Primer, that's not primer. Let's try that again. Primer is needed to start, not stay, start replication. Okay. For our third mark, no prints, primer. For your third mark, you'll need to write then DNA polymerase adds nucleotides to the 3' end. So DNA, nope, that's not how it happens. DNA, no, DNA. Polymerase adds nucleotides to the 3' end. For your fourth mark, you'll need to write that DNA polymerase adds nucleotides in one direction. If you want to, you can say that it adds this in a 5' to 3' direction. Just to amaze the examiner. And one strand, which is the leading strand, is replicated continuously. This is your fifth mark. Still the fifth mark, the other is replicated in fragments. Okay. And for the sixth and final mark, the fragments are joined by ligase. And that is it. That's not ligase. Ligase. Yep, that's everything. There's your 6 marks. Yeah, you can see that. And that's everything you need to know for DNA replication.